Hello, I am Krauter, a PhD student at the University of Stuttgart, and I am now going to present you our work, Sitting Posture Recognition and Feedback, a Literature Review. In this paper, we explored how to support people in sitting healthier and reviewed 223 papers to do so. Looking at sitting is important because we spend a lot of time doing it. In fact, on average, we sit for 5 to 12.5 hours each day. And the negative effects of this prolonged sitting on health has long been shown by researchers. But the solution should be simple. We should just sit less and move more. We have standing desks and we can go for a walk, we can have treadmills, but could we stop sitting entirely? I don't think so. We can reduce it though, but also only to an extent. The problem is that a lot of things in our world are designed for sitting, like cars, chairs, buses, benches, so it is hard not to sit. But we also should not forget that there are people that cannot stand for long, or not at all even. So all of these things might be able to change in the future, but it will take time, and in the meantime, we should focus on how we can sit healthier by looking at our sitting posture. A lot of research has been done on this topic over many years, but I want to summarize the more recent findings with this quote by Biddle and colleagues: "The best posture is the next posture." This means whether we are sitting with a straight back, hunching or slouching, it does not really matter as long as we keep switching it up. Sitting in one posture for a long time is what is unhealthy. So we wondered, how can we and technology help there? And we found that a system needs two components. First, we need to be able to recognize the posture of a person. And second, we have to provide them with feedback so they know how they sit and how they can improve their sitting behavior. Initially, we wanted to study sitting posture feedback, but ran into two problems. First, there was no open hardware available we could easily use, so we had to build our own. After ordering components, we had to wait for a long time due to delivery delays. So we used this time to look into more related work. The second problem is that there is so much work that we were not sure what to use and what is the best approach for both recognition and feedback. So we combined both problems and used the extra time to dig even deeper into the related work. So this naturally brings us to our literature review. We started with repeated keyword searches to find seat papers. And for each paper we included in our review, we looked at all of its references and citations to find more papers to include. The earliest one we found is from 1968, and we reviewed papers up to 2022. And as you can see here, many research fields cover recognizing and giving feedback about sitting posture. There is ergonomics, behavior, sensors, and of course also HCI, but also more. So let's now look at this diverse body of work. For sitting posture recognition, 222 papers detailed some approach. Some used deformation sensors, other distance sensors, and some also combined different sensor types. There were vision-based systems and also motion sensors, and some other lesser used technologies like temperature sensors. The most used sensor technology for recognition, however, were pressure sensors. They are inexpensive, unobtrusive, and easy to use, which is why they are so prominent in related work. Moving on to feedback, only 104 of the papers we found detail a feedback approach. Some of them provide active feedback that pushes the user into a different posture, or a monitor that moves so the user naturally follows this monitor to look at it and in the process change their posture for the better. There were also sound and vibration feedback options. However, most common was visual feedback. We further categorized these approaches and found images and videos, physical objects, which most of the time imitate the user's posture, and text messages. Some used sketches and others charts. There are also some rarer options, and we further differentiated between real-time and summarized delivery of the feedback. Some of the papers detailing feedback also evaluated it with user studies. We found 64 user studies in total, of which 37 were lab studies and 25 in situ. The average number of participants is slightly higher than the SIGCHI average at 15. Most of the studies were comprised of a single short session, and users mainly had to do PC work during the study. The measures that were taken during the studies are task performance, open feedback, comfort, usability, and most commonly, posture behavior. These studies are challenging to compare, more on that later, but overall the results were positive to mixed regarding the feedback's effect on the measures I just mentioned. Some of the studies also found advantage of combining different feedback modalities compared to using only a single one. And this brings us to our results, where I want to share our recommendations for future work and systems. Let's start with recognition again. So we saw that there are many options available and all of these are viable. So in the end, the choice boils down to your task and your user. So if your users need to be mobile, you should use wearable sensors or pressure sensors embedded into a cushion that you can take from one chair to another. We also found that simple setups can be sufficient. So you can start with 4 pressure sensors to differentiate some amount of postures. However, if you want more granular postures, you can easily add more, or even sensors of different types, like a distance sensor. If you need even higher accuracy or want to evaluate other systems, you should use vision-based systems, as these offer the highest accuracy. Integrating recognition into existing devices is something we recommend for the future. This way we can reach as many people as possible, because it will be easy to use and already there, similar to step counts and health monitoring on smartwatches these days. Here we think of a very interesting work by Mollin and colleagues from last year, Aimée poser. Here they used smartphone, smartwatch and earbuds to track full body posture with the embedded Aimée sensors. We think that this holds great potential also for sitting posture. Moving on to feedback recommendations, we find visual feedback to be the best starting point for prototyping. We found it to be the most versatile in the related work and still easy to use. In the end, however, the goal should be to build modular and customizable systems that can adapt to the users and provide benefits to as many people as possible. For example, if someone has low vision or is blind, they would switch off visual feedback and opt for maybe vibration feedback. Or if you are in an office, you would probably turn off sound feedback so you don't annoy your coworkers. We also have some recommendations for evaluating feedback, and here we see a need for better comparability, especially to study long-term effects. Here an example is that the differentiated postures in the studies ranged from 2, so good or bad, to up to 30 postures that were differentiated. And also the effects on health and how to measure them, how to measure the effect of different postures on health, is still unclear. We also think that different settings should be studied more, not only office and PC work. We have leisure time, schools, wheelchairs, and cars and trucks where we sit a lot, and evaluating posture and sitting healthier can benefit many people. Overall, we see the need for cross and interdisciplinary research, where the HCI community comes together with others, like sensors and the health community, to advance our understanding of how we sit and how we can sit healthier. This brings us now to the end of my presentation, where I want to repeat some of the key points of our work. We scanned 11,000 papers from 11 different research fields. Our literature review covers 223 publications from 1968 to 2022. We provide a categorization of recognition as well as feedback approaches, and also analyzed the 64 user studies we found in this body of work. And then we offer recommendations for all of these components for both research and development of sitting posture recognition and feedback systems. For more details, please read our paper, and even more details are provided in tables in the supplementary material. Thank you very much for listening.